Hello and welcome to the Energy Resilience Lab. Our lab is dedicated to giving you the knowledge, skills, and encouragement that you need to become energy independent and to work on becoming resilient in your life. We will be teaching you to help you become resilient. There's lots of different systems. We've already taught you in several of our videos what kind of portable energy storage is to make you resilient. And then we've went into home level. And then today we'd like to get into commercial. So in a commercial setting, you usually have big warehouses using more significant amounts of power compared to home style and size systems. And so if you want to become energy independent, you can use large string inverters. That's usually what I've seen most commonly with commercial buildings. So you'll have a string inverter that's 35 or 60 or 70 kilowatt, and then you can connect all of your solar to the string inverter. So you've got a string of solar cells, and all of that power is getting delivered to the string inverter, and that string inverter is converting it to AC and then putting it onto the grid. And so it's covering your loads in your building when there's solar, and then it's exporting the remainder to get credits from your power company. Usually when you get to this scale, the voltages go up. So more in the home systems, you're going to be 100 to 500 volts on your solar array. Then when you get into commercial, you'll go from 250 volts to 1,000 volt. And then once you get into more large scale, hundreds of kilowatt inverters and beyond, so into the industrial and utility, your solar array will be closer to, it'll be 500 to 1,500 volts DC. See the same thing in batteries. So when you have a battery at your home, it's usually kind of low voltage. A lot of companies use systems that are around 60 volts just because below 60 volts is a better way to say it. So at your top voltage, you don't exceed 60 volt. This is because at 60 volts, the threat of death is apparent. And so if you have a system that's below 60 volts, then if a child gets access to your system, or adults that may not know what they're doing, they may touch things and get electrocuted. And if it's below 60 volts, there isn't really a way for it to kill you. It can still hurt you, it can burn you, but the threat of death is essentially not there. So once you get into more industrial situations, it's usually more isolated, fenced off, everything can be controlled more, so you can use higher voltages. And as we talked about in the power episode a few episodes ago, as we step up the voltage, you don't have to have as much current. And so when you don't need as much current, that means that you can use a smaller wire. So you can scale up the amount of power that you can capture and transport in a wire by changing the voltage and going higher and higher and higher. So that's essentially how it works in commercial, industrial, and utility. With the battery systems, like I was saying, the batteries, once you get into commercial, it is better to get into the higher voltages. So if you double the voltage on your battery, then that cuts the amps that you require in half. So on home systems, you may have a 2-gauge or a single-aught copper wire to transport the power from the battery to the inverter to power it. Once you get into commercial, industrial, and utility, to get into the 500, 700 volt batteries, so that you can really scale up how much power you can operate at with minimal current. And kind of the bleeding edge right now for utility scale, energy storage, and industrial would be 1,500 volts. So they've been using 1,500 volt solar for years in the solar fields and for utility scale and large industrial solar fields, but it hasn't really taken off in the batteries yet until just recently. So now they make systems that are that large, that high enough voltage, so that you can transport the power without using huge amounts of copper or bus bars. You can use wire that are smaller. So just to give you an idea, again, when we talked about the solar cells themselves, once you get into these spaces, you're talking about 1,500 to 3,000 individual cells in your solar panel stacked on top of each other to get to these voltages. So you'd be at 3,000 little silicon wafers in series to get to the utility scale voltage. And that comes with a lot of issues. Like we talked about, if you just have big solar cells and you've got 3,000 of them, if that one solar cell gets covered, the energy from that whole string of solar cells will get reduced, get impeded by that solar cell being covered. So what they do is they will break up the solar panel into essentially 3 to 6 segments. And so each segment is a stack of series cells, and they're all combined with diodes in them to protect from current going the wrong directions. And so the solar power going through it will avoid any regions that are unclean or dirty. So you always, with solar, need to get out there and clean them. But this just minimizes how frequently you have to go out, because if you have a small section that's covered, the rest of the panel can provide power. And so that's another layer of breaking the power down to maximize your power. So you have the maximum power point trackers controlling the power coming from your solar panel. So that maximizes it through the panel, from the panel to the panels on top of that panel. But within the panel, you have all these segments, and they're going to maximize how much current you get through that solar panel. So if you just have the DC to DC, like a micro, not a microinverter, but a DC booster on the solar panel, it's just going to maximize the transmission for the whole stack. Breaking up the solar panel into more phases of solar maximizes the power through that solar panel. So if you have both, then you've got the best of both worlds. So you're maximizing what you're getting out of that panel that has some dirt or problem with it, and you're maximizing through the whole stack. So that just, the smaller increments that you can make gains and the smaller sections that can get covered that still allow current to flow, the higher amount of energy you're going to have over the year. Because you can have a branch or something fall and land on your system, and that could kill the production totally if you don't have these systems helping you distribute the current throughout your array. So there's kind of the ins and outs of kind of the scale and kind of what we use now in the field. Now going forward, there's a lot more energy storage coupled with the solar. So the string inverters, again, are the ones that you just connect your solar array to it and it exports the power. Now we're starting to get high voltage DC co-located, like high voltage DC solar co-located with high voltage batteries, and that can be an amazing combination, because now you can store the energy and become more of a power plant. So the solar can mitigate itself, right? Not the solar, but the battery can mitigate the solar. So it can take the solar power, put it to battery, and hold it until the utility needs it, maximize the effectiveness of that green power that you're providing. So there you go. That's kind of the larger scale. We'll give you more tips and tricks on this as we go forward, and we'll also give you more in-depth information on how the different systems are laid out and how batteries can help you in your business and your industrial spaces to minimize your footprint and to maximize your resilience to keep your systems up. One of the things we shouldn't leave out is that if you add a battery to an industrial facility, it can be very beneficial. So there's kind of the time value of money, where money has value, and so the more, when you tie that up, it costs you something. And with power, you can have large costs associated with the power going out in your industrial commercial space. So I worked with a large medical company a long time ago, probably 8 years ago, and they would lose $3 million an hour for every hour that their system goes down on power. And so they went to the utility and said, we have to have redundant power. I need, do whatever you need to do, get us on different power grids in the area so we're redundant, so we can use one or the other. And they kind of made that as robust as possible. The next level of resilience would be to add a battery system in front of that. So if both of the grids fail or something else goes wrong like that, the battery system can keep you up and running. And so in that case, it just needs to run through the production cycle that is in process to not lose that money. And so having the battery there to support that gives you, can get you that production and give you the money that you would make, and you don't have to throw away that material. Another more recent one I have been working with was a machine shop, and when their power goes down, all the machine tools stop spinning, so they're all in motion, and when the power goes down, they keep moving, but they stop spinning, so it damages the parts and doesn't machine them properly. So they have to scrap every piece that's on a machine. And so in that case as well, having a backup resilient system gives them the opportunity to stop the machine where it is, and then they can allow the power to go out and leave, or they can keep running on the battery power, keep the production going. But usually it's a kind of short duration that they need to run, so they just need enough resilience to keep the machines running and shut them down properly. And in the case of the other, just to finish out that run of production, which may only be a couple hours. You don't have to run, have resilience for the whole day or for all time. But so the utility usually in most of America is very robust, and it doesn't go down that frequently. And so you're really just playing with the edges to make your system ultra robust and resilient. So that's kind of that's why we need energy resilience, kind of when we get into the industrial and commercial spaces. When it comes to more home situations, you're really just empowering yourself to become resilient and energy independent. When you get into commercial, there can be large financial incentives to becoming more resilient and getting systems to help your operations move forward. So that's the commercial and industrial solar. Thank you guys for listening and for liking and subscribing these videos. We'd love to have you ask any questions that you have with regards to how you can implement this, or whatever questions you have on your mind. So please like and subscribe and add your questions after the videos. We'll talk to you later. Have a great day. We'll see you. Bye.